This video is of lesson 83, factoring special products, and it's for my Algebra 1 class. So, ladies and gentlemen, this will be a little bit of a review, but we're going to be doing things backwards from the way we've done them before. So, in the past, we learned that a square of a binomial, so remember this is just a generic binomial, so A is the first term, B is the second term, and then we're squaring it. So the square of a binomial equals a perfect square trinomial. And that perfect square will look like this. So it ends up being the first term squared and the second term squared, but then in the middle, because exponents don't distribute over addition, so there's going to be something extra other than just the two terms squared. In the middle, we find double the product of the two terms. So twice A times B. So ladies and gentlemen, today we're going to be factoring, so we're actually going to be going from our perfect square trinomials to a square of a binomial. So that means that we have to be able to identify whether or not something is a perfect square trinomial. And so really the easiest way to do that is going to be to start at the ends. So if your term is written in standard form, take a look at this first thing in your trinomial, this first term in your trinomial. And is this a square of something? So if that is a square of something, then whatever it is a square of, that's what your A is. So that's potentially what A will be. Look at the last term here, okay? And that needs to be the second term squared. So is this something squared? Is this a square of something else? So if it is, then whatever it's the square of, well, that's B. So that'll be your second term for the answer. Now we got one more thing to check. We got to check the middle. So now that we've identified whatever A is, so this is A squared, so what are we squaring? That's what A is. Over here, what are we squaring? That's what B is. The middle has to, remember, be double the product. So twice as much as if I were to take what A is times B is. So let's take a look at a few examples. Our first example is going to be x squared plus 2x plus 1. And so if we apply what we just talked about here, is this something squared? Yes. So what do we have to square to get x squared? Well, x. So that means in this case, A is going to be x. Now, take a look at the last term here, the constant term. Is this something squared? So is 1 the square of something? Of course, the answer is yes. 1 is the square of 1. So that means that B is 1. So then we got to check the middle. Is the middle double the product of those two things? So x times 1, and then double it, is that 2x? Of course it is. So therefore this is a perfect square trinomial. And we discovered that our A, what we have to square to get x squared, is just x, plus B, what do we have to square to get 1? 1. And there's my factored answer. So let's try another one here. X squared plus 14x plus 49. If you feel like you've got the hang of this, I would recommend that you go ahead and pause the video before I do each example and see if you can do it on your own, and then hit play again to see how you did. But I'm going to keep moving through here. So again, as I look through here, is this the square of something? Well, obviously it's the square of x. Is this the square of something? Yes, it's the square of 7. And then is this the double the product of those two things? Well, x times 7 would be 7x. And if I double it, would be 14x. So sure enough, this is. And so this is x, because that's the square of x, plus 7, because that's the square of 7 squared. So all we're doing is we're moving from our perfect square trinomial back to the square of a binomial to factor. All right, let's take a look at another one here. So I have an x squared minus 8x plus 16. So again, same check as before. Is this the square of something? Yes, square of x. Is this the square of something? Yes, it's the square of 4. And then as the middle, double that product. Well, x times 4 is 4x, double that would be 8x, but this is a negative 8x. So based on what we just said there, this would not be a perfect square trinomial. However, as I imagine some of you are probably sitting at home and thinking, yes, this will still work, because if instead we think of 16 instead of being 4 squared, if we think about it as a negative 4 squared, well then x times negative 4 would be a negative 4x, which when doubled is a negative 8x. So this just means that my b this time is going to be a negative. So when I square it, it does end up with a positive 16. And then when I double it, it ends up with a negative 8. So over here then, my a, this was x squared. We decided that this was a negative 4 squared, so minus 4. So ladies and gentlemen, occasionally, keep in mind, we may have to think of this as a negative squared. Let's look at another example. So for this one here, is this the square of something? Yes, it's the square of x. Is this the square of something? No, it's not. Because remember, we have to treat minuses like negatives. So this is really a negative 16. And negative 16 is not the square of anything. So actually, we would have to say, because of this guy here, that this is not a perfect square trinomial. And the reason for this is because b squared cannot equal a negative 16. So ladies and gentlemen, one of the things that you can check for real quick when you're doing these is this should be a positive term and this should be a positive term because we're squaring them. If they're not, if either one of these is negative, we've run into a little bit of trouble. So, moving on, x squared plus 9x plus 81. So, is this something squared? Yes, it's x squared. Is this something squared? Yes, it's 9 squared. So if this is x squared and this is 9 squared, then double their product should be in the middle. So x times 9 is 9x. But this is not double 9x here. So the trouble here is this guy. Turns out that this also is not a perfect square trinomial. And the reason for that is 2ab would equal 18x, not 9x. So this is not a perfect square trinomial, which means it cannot be factored, at least not as a perfect square. All right, let's keep moving. X squared plus 2xy plus y squared. So for this one, is this something squared? Obviously, yes. X squared. Is this something squared? Yes. Y squared. So is the middle double the product? Well, x times y doubled would be 2xy. So actually, yes, this is a perfect square, where the first term is x, because that's what we're squaring here. And what are we squaring there? Y. So ladies and gentlemen, it is possible in these problems to have multiple variables. So when that happens, you just go back to the questions we keep asking. Is this something squared? Is that something squared? And then as the middle, double the product of those things. Next example, 4x squared minus 12xy plus 9y squared. All right, so we want to see if this is a perfect square trinomial. So is this something squared? Is this first term, 4x squared, is that something squared? Yes. If we take 2x and square it, we'd get 4x squared. So A, our first term, will be 2x. Over here, is that something squared? Yes, it's 3y squared. So my second term would be 3y. So this is 2x squared. This is 3y squared. Is the middle double the product? Well, a 2x times a 3y would be 6xy, which if we double it would give me a 12xy. Well, the trouble here is we got that minus, but just remember, ladies and gentlemen, all we got to do then is go back and think of this instead of as a positive 3y squared, think of it as a negative 3y squared, and we're in business. So then this will actually be a 2x minus a 3y squared. So ladies and gentlemen, hopefully you're starting to pick this up, that these two terms on the outside should both be positive, and then the middle one, if it's positive, it'll be a plus. If it's negative, that'll be a minus. All right. So that was a little bit harder. We're going to do another couple here that are going to be a little bit more challenging. So for our next one, we're going to go pi x squared plus 10 pi x plus 25 pi. So is this something squared? So can you square something to get pi x squared? No, it's not a perfect square. Nothing nice. I mean, for one thing, pi is not a rational number, so that's kind of a giveaway there. But even symbolically, leaving pi as a pi symbol, there's nothing here that would be a nice symbolic answer. So we'd have to say no here. However, notice, and I'm sure you did, that each one of these terms has pi in it. So one of the things that we will do from time to time is we will take a quick glance and we'll see in the course of factoring, is there anything we can factor out of each term first? So this may not actually be a perfect square trinomial. This is not. However, could it be a multiple of a perfect square trinomial? If it is, then we can factor it. So the first thing I'm going to do here is I'm going to factor out what I can. So noticing that there's pi in each of these, let's go ahead and factor the pi out. So I factor pi out, I'm left with an x squared plus 10x plus 25. Now, from what's left over there in the quantity, x squared is x squared. 25 is 5 squared. So x and 5 makes 5x. Doubled is 10x. So it turns out that what's left over here is a perfect square trinomial. So while this original one is not a perfect square trinomial, it actually still can be factored if we just factor out what we can first. So now what did we square to get this? X. What did we square to get that? 5. Oh, that looks like I've forgotten to circle a few answers here. All right, and our next example will be a negative x squared plus 16x minus 64. So first things first, is this first term something squared? So is there something you can square to get a negative x squared? Obviously no, because when we square something, we don't end up with a negative. We run into the same trouble over here. And that actually ends up being a good thing. The fact that we have the same trouble on both of these just means that we can factor out that trouble. So this time, I'm going to factor out my negative. And so when I do that, factor out a negative out of this, that'll leave me with just x squared. Factor a negative out of a 16x, that'll actually become a negative 16x. So think of plus as minus a negative. So if we factor a negative out there, we'll just be left with a minus. And then factor out a negative out of my minus 64, leaves me with a positive 64. If you want to double check that you did that correctly, just distribute the negative back in and make sure it goes back to the original. Now that I've factored out that negative, let's take a look and see if what's left over is a perfect square trinomial. So x squared is x squared. 64 is 8 squared. Since that's a minus there, though, I'm going to think of this as a negative 8 squared. And then if I take an x with a negative 8, that'd be a negative 8x. Double it is a negative 16x. So yes, what's left over is a perfect square trinomial, where the first term is x and the second term is negative 8. So that ends up being whatever x minus 8 is squared and then turned into its opposite. So, ladies and gentlemen, just to re-emphasize down here, remember that if we have a minus b squared, and we kind of discussed this above, you're still going to have your a squared, you're still going to have your b squared. It'll just be a minus 2ab here. So that this symbol will match that symbol. And now we're going to go ahead and flip our pages over, please. I'd like to keep all these problems together. So flip your page over. And we're going to review one more concept and do just a few more examples. And so our last special product that we're going to take a look at here is the product of conjugates. So remember, in order to get conjugates, we have two binomials which have the same first terms and the same second terms. The only difference between the two is one is an addition and one is subtraction. So a plus b times a minus b. And whenever you have a product of conjugates, this ends up equaling a difference of squares, where we have the first term squared and we have the second term squared. And we subtract them. So for factoring purposes, ladies and gentlemen, we're going to be looking for moving from a difference of squares back to a product of conjugates. So that means we're going to be looking for situations where we have a difference of squares. So do you have something squared minus something else squared? So for example, x squared minus 4. So we ask ourselves, is this something squared? Yes, it's x squared. Is this something squared? Yes, it's 2 squared. So my first term is x, my second term is 2. And so this will be x plus 2 times x minus 2. So difference of squares actually can be pretty simple. All right, let's take a look now at what if I have x squared minus 144. So this is the square of x. This is the square of 12. And so since we're subtracting them, this will be x plus 12 times x minus 12. X squared minus 7. So is this the square of something? Yes, it's the square of x. Is that the square of something? Well, nothing rational. However, we could split this up if we wanted to. Typically, though, we wouldn't split that up. But if we wanted to, I'm going to do this in red pen. we would just say 7 is the square of what? Well, 7 is the square of the square root of 7. So we actually could split this up into x plus the square root of 7 times x minus the square root of 7. And that actually is going to help us later on as we do more with radicals, and particularly getting rid of radicals, going from things like this to now having no radicals. But that's on a future lesson. So this one right here, you would just say, no, not a difference of squares. And the trouble here is that b squared cannot equal 7. 7 is not a perfect square. Moving on, next example, 36x squared minus 25y squared. Well, this is the square of 6x. This is the square of 5y. And it is a difference, so therefore we can turn this into conjugates. 6x plus 5y times 6x minus 5y. Next up, negative 64 plus x to the fourth. Now this one raises a little bit of trouble in that this is not a difference. This technically is a sum with a plus between it. However, ladies and gentlemen, if we just do some quick thinking, and for those of you who it would help, you could actually write this out in pencil. But if we just do some quick thinking, we can flip this around. We know that this is really going to be x to the fourth power plus a negative 64, which we can then just turn into minus 64. So a quick little rearrange there, and we are back in business. So now this one, though, throws an extra little trick at you. So if we consider this is this the square of something? That's what we got to ask ourselves. Is this the square of something? Well, would you have to square to get x to the fourth power? Well, it turns out that if you square x squared, remember, a power to a power, we multiply these exponents. So 2 times 2 would be 4. So it turns out that, yes, this is the square. Something is the square of x squared. And this is the square of 8. So therefore, this is x squared plus 8 times x squared minus 8. And there it is. And we're going to finish off with one last example along the same lines, x to the fourth power minus 16. So I would encourage you to pause the video here and see if you can give this one a shot on your own and factor it completely. All right, here I go. Is this the square of something? Yes, it's the square of x squared. Is this the square of something? Yes, it's the square of 4. So this will be x squared plus 4 times x squared minus 4. And if you got that for your answer, you are wrong. Now, what you wrote is not incorrect, but you're wrong because you're not done. Because if we look at these, well, this is a sum, so there's nothing I can do with that. However, this is a difference. So in this difference, do you have a difference of squares? Well, this is x squared, and 4 is really 2 squared. So actually, this can be factored further. So we're still going to have x squared plus 4. But now this is x squared minus 2 squared. So this can be split up into an x plus 2 times an x minus 2. So that's something to watch out for on the homework, is that if you end up with something like this where you have a higher power variable something like x to the 4th, x to the 16th, something like that, that can be then split up is, do you end up in a situation where you have another difference of squares that can be factored further? And that, ladies and gentlemen, is the end of our lesson.